We have talked about functions before, so this is a continuation of that. So you can look up here if you want to go back to the first part. So a function is a rule that when you give it a number, it will give you another number in a deterministic way. So here, this is just a symbol for the number you get out. So you can think of this as an apparatus. The function is an apparatus where you put in the number x, and then it spits out number y. So if you have the apparatus here, then you put in x, then the apparatus will give you out precisely one number y. So this function gives you the square of the number you put in. For example, if you put in 0, you will get out 0. And if you put in 3, you will get out 9, and so on. If you put in x equals to -3, then it will also give you 9 out. But that's okay. For two different numbers in, it can give you the same number out. But for the same number in, it cannot give you two different numbers out. Let us look at some typical examples of types of functions. So polynomial are functions of this type, for example, 2x plus 1, 6x3 minus 2x squared plus square root of x minus 11. So these are typical examples of polynomials. So the variable x, you have that to natural number powers, and then you have constants in front, and then you have a sum of those. More generally, you have a function f of x is called a polynomial if it can be written in the following way. So here, an minus 1, a2, a1, all of these are constants. And then we have powers of x. The largest integer here, that's called the degree of the polynomial. So this is a polynomial degree 1, this is polynomial degree 3. Then we have exponential functions, and that's a function in this form. So a constant raised to the power of x, where x is a variable. For example, f of x 2 to the power of x, or 10 to the power of x. Note that we will also call a function have a constant in front, an exponential function. Here we have some examples of exponential functions. So we see for different values of a. So when a is larger than 1, then it will be steeper and steeper. Then for a equal to 1, we're horizontal. And when a is smaller than 1, it will decrease. A logarithmic function is a function of this form. So you have the a logarithm of x, and here a is a constant, and x is the variable. Examples of logarithmic functions are this one and this one, where log just means log 10. And here ln x means the logarithm for Euler's number. And Euler's number is an important number in mathematics. Have an important role, just as pi, for example, has. And it's equal to 2.7182. Infinitely many decimals. This is an irrational number. We will not talk so much about Euler's number in this course. This one is also called a natural logarithm. And here we have some examples of logarithmic functions. So for log 2, log e, and log 10. Then we have trigonometric functions. For example, these ones. Note that when you deal with functions, often x is given in terms of radians instead of degrees. And here we see the graphs of those trigonometric functions. So we see that they are wave-shaped, apart from tangents x. And the functions are also periodic, meaning that after 2 pi, they will come back to the same value. But tangents x will come back to the same value after pi. If you have functions, you can combine functions to new functions. For example, if you have a function f of x, then you can add another function g of x, and you get another function. For example, let's say that f of x is equal to x squared, and g of x equal to 3x plus 4. Then the sum of these will be x squared plus 3x plus 4. Or you can take the difference. In this case you will have minus 3x minus 4. Or you can take the product of two functions. In this case you will get this. You can also take the quotient. So in this case you get this one. Then you can also make function compositions. So if you take one function and put that in to another function, then you have a function composition of f and g. You can also write this as f of g. That's just another way of writing this. For these two functions we will have that g of x is equal to 3x plus 4. So now you should put in this in the place of x in the other function. Then you will get this. If you do the opposite composition, so you put in f of x in g of x, then in general you will get another function. So here f of x is x squared. And if you put x squared into the place here of g, then we get this. And you see that in general these two will not give you the same number. So there are two different functions. So this you can write like this instead. So you see in general composition of functions are not commutative.